Hello everyone, my name is Newman Waters and I'm going to walk you through Project Zero. So to start, you're just going to click on the link on the assignment and you'll see this accept the assignment. Every single project will start like this. So you just click accept the assignment and this will create a repository for you. And you just click on it like this, it'll tell you when it's due and it'll have some stuff already in there, right? So there's going to be some instructions. It'll just say, here's what you have to do. For this first project, since it's ungraded, it's really just to help you get started. So it's just telling you some basics about accessing Vivado, what are the best ways to do that. And then there's the instructions on what to do. And what you should always do is you should, first of all, clone the repository onto your local machine. So I just like to use VS Code. And once you've authenticated yourself via SSH, you can set up SSH keys, or you can use the source control tab on VS Code or some other way using GitHub Desktop, whatever you'd like. You can clone things very easily and get access to all your files here. All right, so I can view the README all locally if I want. It's going to be exactly the same. But at least now we have access to the files that we might need. So let's just walk through it, what we need to do, and get started. So first step, create a Vivado project. So once you've installed Vivado, you start it up. So let's get that started. So you can start it up like this if you add it to your path. If you're using Linux, if you're using Windows, I think you can also do that. Or you just have a desktop shortcut. But let's go ahead. So when you first start, you'll see something like this. You can just click create project, next. So just name it something, I don't know, just for this I would just say Project Zero. And then for the location, I would suggest creating a dedicated folder just for Vivado projects. Now I have a folder called Vivado 2021 projects. That's the version I'm using. So I'm just going to put that there. And so it'll create Project Zero. Okay, it's going to be an RTL project, so you don't need to change anything. It'll say add sources, add constraints. We have constraints in this project, but I'm going to just leave it for now so that I can show you where you'll do this. And then for the board, we're not going to use a board, we're just going to put a part. So we can go into the actual instructions here and just take this part number. Let's open up Vivado, search for that part, and it'll just be the first one here. Click next, click finish, and so we see it says family Spartan 7. Looks good to me, so I'll just say finish. And there we go. So we've got a project going, and now is when we'll add our constraints file. So we'll add the constraint file to the project. The way you can do that is by clicking the plus, and then clicking add or create constraints, and then add files. So you saw that we cloned our repository onto our machine, somewhere. So what I can do is I can go navigate to that folder. So I put it here. So this is the repository I just cloned, and you see the XTC file is the one that you're going to want to put in. You could copy it, but I like to just leave it uncopied because then I can make edits to the file in VS Code or my text editor, and then I can just save it here and it automatically updates in Vivado. It's just a lot easier. So the file in Vivado here, these are actually the same file because we didn't copy it over. They're referring to the same thing. And of course, if I change something, I don't know, and save it, you'll see, yeah, so it says it's been changed, so you can reload it. And yeah, so that's just a lot easier. All right, so next step, we need to create a block diagram. So very simple, create a block design. You can just leave it named design 1. It's not really that important, so just stick with the defaults. And now that we've done that, we have this empty canvas that we can now place components on. And so in our example, we're just asking you to create a very, very, very basic circuit, which is just a logic gate with 2 inputs and 1 output, as well as just a constant. So in Quartus, I think you knew how to do this on the schematic, but Vivado, it's a little bit different. Everything is considered IPs, right? You can't just drag gates because this is more of a system level software. So you have to, select out of this big library of stuff that they give you. So the ones that we're going to need for this one is this utility vector logic, as well as this constant. So let's go ahead and add the first one. So I'll just search up utility vector logic. It might be named differently depending on the version that you're in, but if you search up some combination of whatever this is, it might be inline utility vector logic, might not. I don't know for sure, but just search it up until you find it. And so what you notice here is that the gate that we've been given is 8 bits on each input. So we have an 8-bit, 8-bit, and then 8-bit here. And so we want to change that obviously to 1 bit. And so the way that we do that is we go right click it, customize block, and you can just change it to 1 for the size. And then if you wanted to change the operation that it was doing, then you would click that here, you click OK, and that's it. That's all we have to do to change the size. And now to actually make the pins that we're going to need, to bring in inputs and outputs, you can just click on the pin that you want to, edit, click make external, and then do that for all of them. That's not what I meant to click. Make external, make external. And so, these things get named automatically. You can technically change them here, but since we provide you a constraints file that refers to those with those pin names, it's probably easiest to just keep them as the defaults, right? And if you do decide to change these pin names, well, you should go into the constraints file, look at the specific thing that you changed, and then go make sure that they match, right? Okay, so now that we have our AND gate done, let's add the constant. So it should just be a constant 0, I believe. But, well, we'll see, I guess. And so you can just drag this in wherever you want, and we'll just move over a little bit, and we can see what it is, I think. So if we customize block, it says the value of the constant is 1, width of 1. So this means that whatever this thing, it's basically generating a constant on value onto the wire. So we'll just make this external as well. Very, very simple. And then we have a wire here that's always on. So whatever this is connected to, which in this project it's connected to an LED, it should always be on. And that's it. And we can make sure that we have these 2 outputs attached to LEDs. So in the constraints file, you'll see this stuff. It's already provided for you. Basically, you just uncommented out the LEDs I wanted to use, which are these 2 pins, and then just named the ports based on the diagram. And then obviously the 2 inputs are those 2 switches on the very right side. So pins G1 and F2. And then that's all we have to do. So I'll save. So I'll do Control S. Looks like it's all good. And then what I have to do now is we can't instantly synthesize this block diagram. We have to actually turn it into HDL first. So how I do that, I right click the block diagram, create HDL wrapper, let Vivado manage wrapper and auto update. Good. So that's all we need to do. And this will create VHDL or Verilog for our block design. And then this is what will then eventually be synthesized and routed, placed and routed. So let's look at the HDL that's generated just quickly, just to make sure. So you see there's some code here, and then it shows the hierarchy here. If you want to change whichever one's the top level, you can just right click and click set as top. Now it automatically put the right one at the top, but if you wanted to change this for whatever reason, if you're doing a different design, that's how you would do it. Here you can say set as target constraint file. You don't necessarily have to do this if you've only got 1 constraint file. I would just suggest doing it. You might have multiple, but it just makes it say that it's target. That means that we're gonna flash the board with these constraints. So we're ready to generate the bit stream. So we need to start the synthesis. and then we have to implement it. So that's the routing and placement, and then we'll just generate the bitstream. So we can do that by just clicking the generate bitstream button over here. Just click OK, and it'll go ahead and do all of those steps for us. And you can see what it's going to do is it's just going to do these 2 steps. And then by the end of this, hopefully we get something that works that we can then flash onto the board. And I'll show you how to do that. Okay, so after all of those steps, you see you hopefully have bitstream generation successfully completed. If not, then maybe you made a typo, maybe you didn't connect something right, maybe a pin doesn't exist. I don't know. Those are the things that you'll see. You can always look in the logs, which are located after this thing opens up. They're located here. You can also look at the messages. This one's really helpful because it'll have like errors, so it'll be pretty obvious what the issue is, I think. Here's the implemented design. This thing doesn't really matter for us. We just want to get it working on the board. So the easiest way to get this done is to just open the hardware manager. And then, so let me plug in the board now. So now that it's plugged in, you should see like a blue light on your, board. But if the green status lights are not on, then there's something wrong. So make sure to turn that switch on the top right. And then you can click Open Target, Auto Connect. And hopefully you see the FPGA there. And so all we have to do is just click Program Device. It automatically finds the bitstream file for us, so we can just go ahead and do that. So now that I've done that, the board, now I know that you can't see it, but the board right now in the default state with all the switches down should have one LED on the right. And if we look at the block design, we can very clearly see why that's the case, because the first LED is attached to this wire, which should always be on. The second LED should be off, but if we turn the first 2 switches, the 2 rightmost switches, we'll see LED 1 turns on as well. So that confirms that our design works and that the board is functioning as expected. So now that we finished this, we need to go ahead and submit our bitstream, and we can do this by actually going to the folder in which this project is located. So for my case, it's in the Vivado 2021 projects, project 0, and I'll open up my file stuff and find that right now. So Vivado 2021 project 0, and then so now that you got here, you just click .runs. This means all the products that are created, implementation, and so this one, the one that says .bit, is the one that you really want. So you can literally just copy it, Control-C, and then paste it into your repository. And then we can go ahead and push it. So let's do git status. I'm not in the right place. Man, project 0, name HW, and now let's check. So now we're here. I modified the constraints file, but that was just to show you. So I'm just going to add that bit file. So now it's ready. So we're going to do git commit added bitstream, and then git push, and then let's check that it's there. And so you see now my commit, now that said added bitstream, it's there. So the file's here. Now we as the TAs will be able to download it or run it or whatever, but for most of the submissions you'll need to provide the bitstream as well as a couple other things, maybe a report, as well as all the source files that you do. In this case it's not a huge deal because we obviously are just making something very basic, but the next projects will be very explicit on what you need to provide. So with that, thank you for watching. I hope this helped, and if you have any questions, please feel free to help to ask us in the Slack.